Hi, today we're doing notes for 11.6, events involving not and or, and we're also talking about odds. According to the Harvard Center, the odds in favor of a fatal shark attack are 1 to 280 million, and the odds against a fatal airplane accident are 3 million to 1. We can determine the odds in favor and the odds against such events as these. First, we're going to find the probability that an event will not occur. So the complement. The event not E is the complement of E because it is the set of all outcomes in the sample space S that are not outcomes in the event E. The sum of the probability that an event will occur and the probability that it will not occur is 1. Here are the complement rules of probability. The probability that an event E will not occur is equal to 1 minus the probability that it will occur. And similarly, the probability that an event E will occur is equal to 1 minus the probability that it will not occur. Using set notation, if E apostrophe, that's going to stand for the complement of E, then the probability of E, or I'll call it E prime, is equal to 1 minus the probability of E, and the probability of E is equal to 1 minus the probability of E prime. If you are dealt one card from a standard 52 card deck, find the probability that you are not dealt a diamond. So, for example, on this one, we have 4 suits, and one of our suits is diamonds. Okay, so our probability of getting a diamond would be 1/4. So if we want the probability we are not dealt a diamond, we can do 1 minus 1/4, which gives us 3/4. If one driver is randomly selected from the population, find the probability expressed as a simplified fraction that the person A is not in the 50 to 59 age group. So if I look here, my total is 191 million. So if I want the probability that they are in the 50 to 59 age group, we can see right here, this is 31 million. So this is 31 divided by 191. And so if I want the probability that they're not in the 50 to 59 age group, we can do 1 minus 31 over 191, which will give us 160 divided by 191. I would like you now to find the probability that the person is at least 20 years old. Okay, so in this case, we want the probability that a person is at least 20 years old. So we're looking for the probability that they're 20 or older. Now, if I'm looking at my chart here, I have, that means 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, and greater than 80. So it's everything except the group that's less than or equal to 19. So this one is actually easiest to find if I do this as 1 minus the probability that the person is less than or equal to 19. So I can do 1 minus my probability less than or equal to 19 is this one right here, 9 million. So this is 9 over 191. And so then I subtract this, and I'm going to get 182 over 191. Okay. Find the probability of one event or a second event occurring. So mutually exclusive, this is when it is impossible for events A and B to occur simultaneously. Or probabilities with mutually exclusive events. This is if A and B are mutually exclusive events, then the probability of A or B is going to be equal to the probability of A plus the probability of B. We're using set notation. If you recall, an OR is the union, and so that is this symbol. Again, for OR, you can use the union. So that would be probability of A plus probability of B. So here's our question. If you roll a single 6-sided die, what is the probability of getting either a 4 or a 5? So our probability of a 4 is 1/6. Our probability of a 5 is 1/6. So our probability of a 4 or a 5, we take 1/6 plus 1/6, which gives us 2/6 or 1/3. Or probabilities with events that are not mutually exclusive. If A and B are not mutually exclusive events, then the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Using set notation, again, this is probability of A or B equals probability of A plus the probability of B minus the probability of A and B. All right, so this one says in a group of 50 students, 23 take math, 11 take psychology, and 7 take both math and psychology. If one student is selected at random, find the probability that the student takes math or psychology. So we want the probability that the student takes math or psychology. So that's going to be our probability of math plus probability of psychology minus the probability of math and psychology. Okay, so we know that 23 take math. So this is 23 out of 50 plus 11 take psychology. So 11 out of the 50 minus the 7 that take both. So this is 7 out of 50. And if we combine these, we end up with 27 out of 50. Our next one says use the spinner to find the probability that the pointer will stop on an odd number or a number less than 5. I want you to take a minute and try to do this one, please. Okay, so we want the probability that our spinner is going to land on an odd number or a number that's less than 5. Okay, so this is our probability of odd plus our probability that it's less than 5 minus the probability that it's odd and less than 5. All right, so my odd numbers. We have 1, 3, 5, and 7. So these are our odds. Again, I'll also circle these. It's a little hard to see my highlighting. So we have 4 out of the 8 are odd. Probability that the number is less than 5. So in this case, I'll underline them. Probability it's less than 5. So we have 4, 3, 2, and 1. So we have 4 out of the 8 that are less than 5. Now, odd and less than 5, this one I'll circle with a different color. So odd and less than 5, we see that we have 1 and 3 that fit that criteria. So minus 2 out of 8. So we simplify and we end up with 6/8 or 3/4. If one person is randomly selected from the population, find the probability of the following. Express probabilities as simplified fractions and as decimals rounded to the nearest hundredth. So for our first one, and actually I think we're just going to do simplified fraction. We're not going to worry about the decimals. The first one we have the person is married or female. So we know we need the probability that the person is married or female. So that's going to be probability that they're married plus probability that they're female minus probability that they're married and female. I'm using M for married and F for female. And so if we want the probability that they are married, we're looking at our total here is 130. Our table total is 242. So this is 130 out of 242 plus probability that they're female. Our total for that is here 124 out of the table total 242 minus the probability that they're married and female. So if we look here, females that are married is 65. So minus 65 out of 242, and that will give us 189 out of 242. B says the probability that the person is divorced or widowed. I would like you to try to find this one, please. Okay, so probability that the person is divorced or widowed is going to be the probability that they're divorced plus the probability that they are widowed. And let's think, if I look at this, divorced and widowed, if you notice, both are columns, right? So a person, we're assuming that they're not going to be divorced and widowed, right? If they're married multiple times, that could happen. But in the purpose of this chart, divorced and widowed, they have no overlap. So we don't need to subtract the probability that a person is divorced and widowed like we did for part A. So in this case, we have the probability that they're divorced. This is 24 out of our table total 242 plus the probability that they're widowed, which is 14 out of 242. And so that gives us 38 out of 242. And this one does reduce to 19 divided by 121. Okay, understanding and using odds. Probability to odds. If the probability of E is the probability of an event E occurring, then the odds in favor of E are found by taking the probability that E will occur and dividing by the probability that E will not occur. The odds against E are found by taking the probability that E will not occur and dividing by the probability that will occur. So again, if you want odds in favor, that means you're putting the event happening in the numerator. If you want the odds against, you're putting the probability that the event does not happen in the numerator. So you have to pay attention to the wording because that will dictate what goes in the numerator and what goes in the denominator. So we have here the odds against E can also be found by reversing the ratio representing the odds in favor of E. You are dealt one card from a 52 card deck. Find the odds in favor of getting a red queen. So you want the odds in favor of getting the red queen. So odds in favor, there are 2 red queens. And then the rest of the deck would be 50 not red queens. So our odds in favor, we could say this is 2 out of 50. Sometimes people write odds 2:50. Or the preferred way is if we write this in reduced terms. So this would be 1 to 25 or 1/25. Find the odds against getting a red queen. Go ahead and do this one, please. So if we want the odds against getting a red queen, we know that we have 50 not red queens. And we have 2 red queens. So this would give us our 50 over 2, or 50 to 2. Or if we reduce it, we could write it as 25 over 1, or 25 colon 1. And if you notice, because we're just doing the odds against, the same thing that we did for A, you can actually just take the reciprocal to get the answer here. The winner of a raffle will receive a 2-year scholarship to the college of his or her choice. If 1,000 raffle tickets were sold and you purchased 5 tickets, what are the odds against your winning the scholarship? I want you to try to do this one, please. Okay, so you purchased 5 tickets, and it says that we want to figure out the odds against your winning the scholarship. So, because you purchased 5 tickets, you have 5 chances to win and 995 chances to not win. So, we want the odds against your winning. So we do 995 divided by 5, or you could write 995 colon 5. Or if we reduce this, 199 to 1, or 199 to 1. Odds enable us to play and bet fairly on games. Using odds in a gaming situation where money is waged, we can determine if the game is fair. If the odds in favor of an event E are A to B, the game is fair. If a bet of $A is lost, if every event E does not occur, but when a bet of B dollars, as well as returning the bet of A dollars, is realized, if event A does occur. So odds to probability. If the odds in favor of event E are A to B, then the probability of the event is given by, the probability of E is A divided by A plus B. Again, remember, odds in favor are A to B, odds against are B to A, right? So we have the A and B, if we combine them, that gives you the total number of possibilities. That's why we're adding them for the denominator. So it says the odds against a particular horse winning a race are 15 to 1. Find the odds in favor of the horse winning the race and the probability of the horse winning the race. So I want you to take a minute and try to do this one, please. Okay, so we want the odds in favor of the horse winning. So the odds for the horse winning. If the odds against our horse winning are 15 to 1, then the odds for the horse winning are just going to be 1 to 15. We can just take the reciprocal there or flip it. So now if we want the probability of the horse winning, we're going to take, this is 1 divided by 1 plus 15, which gives us 1/16, which if we wanted to write this as a decimal to see what that probability is, this is 0.0625, or about 6.25%. And that's all we have for today.